Hello and welcome to homework help for lesson 6.9, the properties of logarithms. For today's homework, we are going to address numbers 1, 2, and 3. So before we get started, let's just talk about a couple of the basic rules. So some of the properties of logarithms that you may already know are that you cannot take log of a negative number. In fact, if you see that, the answer is does not exist, or you might have seen in your book the word undefined, and those both mean the same thing. So log of a negative number does not exist. Same thing with log of 0. The answer is also does not exist or undefined. And just to prove it really quickly, I'm going to go ahead and write something like log base 3 of 0. Let's evaluate this. So I'm going to set it equal to x. And I want to see what this equals. So I'm in log form. I'm going to go into exponential form. So I'm going to take my base. 3 to the power of x equals 0. So what could x be? 3 to which exponent could give us 0? Well, if we try an exponent like 1, 3 to the 1 is 1. 3 to the 0 gives us, 3 to the 1, I'm crazy, is 3. 3 to the power of 0, well, anything to the 0 gives us 1. Let's try negative numbers. 3 to the negative 1, well, that gives me 1 over 3. And I could keep trying, but I'm never going to hit 0. So that's why our answer is simply does not exist. There is no exponent that will take your base and then get you to 0 afterwards. So please memorize these two rules. Don't even bother trying to figure it out. Just got to know it. Put it in your toolbox. Make it easy on yourself. Log of a negative number is log of a negative number is undefined, and log of 0 is undefined. Now you're learning a new rule. This one's called I call it the product or quotient rule. Okay, and this is what it says. If I have log of a whole bunch of terms being multiplied and divided together, this is what the properties of logs say. Each of these products, or each of these pieces that's multiplying, let's see how many we have here. 1, 2, 3, 4, 5, 6. Each of them is actually going to get their own log, and it looks like this. Log of A plus log of B. Each is getting its own log plus log of C. And I would keep on adding as many more as there are in the numerator. I would keep adding the rest of them. Now I'm going to deal with D, E, and F. Since they're in my denominator, they get minus signs in front. So that would be minus log of D minus log E minus log F, and so on. I would keep subtracting any more that appear in the denominator. So here's the big thing to take away from this rule. All the logs that are in the numerator, A, B, C, have a positive in front of them. So if it's plus, in front. If it's a positive log, it's going to be in the numerator. However, all the logs that have a minus sign in front, so log of D and E and F, those are all going to go into the denominator. If it's a negative log, it's going to go into the denominator. So let's look at this example. Using our rule that we just came up with, we're going to expand this logarithm. So I'm going to write equals. Now let's see how many logs we should end up with. Remember, each product or each piece that multiplies gets its own log. So I have a 5 times x. That's 2 in the numerator already. And then in the denominator, I have 3 times A times B. So I have a total of 5 pieces here. 1, 2, 3, 4, 5. So let's start with our numerator. We're going to have log of 5 plus log of x. They're both positive in front because they're in the top. Now I'm going to deal with my denominators. So I'm going to switch to negative. So minus log of 3 minus log of A minus log B. And that's how we will expand that. Okay, let's do the last one. It says natural log of 2zw over 7c. So see if you can try it yourself. I'm going to start at the top. I have 2 times z times w, so each of them is going to get its own log. Now I'm dealing with ln, so I'm going to write ln of 2 plus ln of z plus ln of w. I'm moving into the denominator now, so we need to use minus signs. Minus ln 7 minus ln c. So now I want you to teach you one more rule. It's called the power rule. And this one's dealing with exponents. So notice so far we had no exponents. Now I'm going to teach you a rule for exponents. If we have log of a to some exponent b, actually the way the power rule works is you simply take that exponent and move it to the front. It becomes this, b times log of a. So observe, for our first example, I'm going to take that power, move it to the front, so that's the same as 3 log x. Pretty cool. The next one's a little more challenging, and that's because I don't see an exponent here. But when you have a square root, remember that the square root of x is the same thing as x to the power of 1/2. So really, we have a kind of hidden exponent of 1/2. We have to write it in. So and also another note, if I have the cubed root of x, that's the same as x to the 1/3. So keep in mind your power, your roots, and converting them into exponents, how that works. So our first step for this example here is we need to write in our exponent. That's log base 5 of y to the 1/2. Now that I see my exponent, I can move it to the front. And so my final answer is 1/2 log base 5 of y. Let's do this last one at the bottom. I have ln of 2x plus 1 whole squared. So this is my exponent. I simply move it to the front. My answer is 2 ln of 2x plus 1. Here's all I did. I took it and I moved it to the front. Now that we have our power rule as well as our product and quotient rule, I'm going to combine them. Let's merge our rules. See if you can follow the logic, okay? I'm not going to tell you what I'm doing at first, but I want to see if you can identify the pattern. So, our top example here, the answer is going to be, if I expand this, it's going to be log, let me use a different color. Since I'm in the numerator, I'll use blue. Okay, log 3 plus, because I'm in the numerator, now I'm dealing with x cubed. That's going to be 3 log x plus 4 log y. Do you see what I'm doing? In the denominator, I have 2 and I have square root x. So I'm going to do minus log 2 minus 1/2 log x. See if you can figure out how I got from the left side to the right side. So each of these pieces up top was being multiplied. So I had 3 separate positive logs, 1, 2, 3. And then for the x cubed, instead of writing plus log of x cubed, I just moved it to the front already. That's why I got 3 log x. Same thing with y to the 4th. I wrote that as 4 log y using my power rule. In the denominator, here's the tricky thing I did is I crossed out in my mind. I crossed out that square root and I knew that it was a power of 1/2. So when it came time to writing minus log 2 and then minus the log square root x, I just wrote my power instead of writing it here. I already moved it to the front. So it's minus 1/2 log x because of the square root sign. Okay, let's do the next one. Let's practice again because this is really going to be super, super easy just by doing several examples. So try it with me. So we're expanding this. Right now I have one big ln. How many ln's are we going to end up with if we expand it out? See if you can count all the products or all the pieces that multiply. We're going to have 1, 2 in the top, and in the bottom we're going to have 1, 2, 3. Now before we move anywhere at all, if you see a root, I would like you to immediately rewrite that as an exponent. So that's going to be a to the power of 1/3. All right, let's do this. So our first product is 6. So I'm going to give it its own ln. ln 6. I'm still in the numerator. I have a to the 1/3, so plus 1/3 ln a. We're in the denominator now, so each of these gets its own. And here's what I really want to emphasize. This power of 2 only applies to the y. It's not applying to the x. So the x needs to just chill on its own. It's not going to have an exponent. So we're going to write minus ln 5 minus ln x, not minus 2 ln x, because the x isn't being squared. So just minus ln x, and then minus 2 ln y. Finally, I can take care of that exponent. Last one. Okay, this one's a little different from the ones we've done before, and that's because I actually have a plus sign for the first time. So in the top, I'm not going to write two separate logs for these because they're not being multiplied. Remember, only the pieces that are being multiplied get their own logs. So here, we actually have invisible parentheses around the x plus 1. Anytime you have a plus or minus, you're going to stick invisible parentheses around them. So in the top, I actually only have one piece, but in the bottom, I'm going to have 1, 2, 3 different logs, or 3 different factors here, products. Sorry, not products, pieces that multiply. Okay, so the first one's going to be, now notice we have this log base 4. We need to keep that in mind. So I'm going to write log base 4. Our first one is x plus 1. Why did I leave it positive in front? Because the x plus 1 is from the numerator. Next, minus log base 4 of 4. I'm still in the denominator, so minus 5 log a. I took this 5, moved it to the front, and then minus 6 log b. Awesome. So there is one thing that I can actually simplify here, and that is this log base 4 of 4. So log base 4 of 4, if you put it in a calculator or you remember how logs work, is basically 4 to the which exponent gives me 4, and the answer there is 1. So log base 4 of 4 is just 1. So this would be my final answer. Ta-da! So that was kind of fun. It's almost like a puzzle, like a game with some rules you got to follow. Now we're going to go backwards. So instead of taking this single logarithm and then expanding it into many pieces, we're going to move backwards. We're going to take the many pieces over here on the right side and condense them so that it becomes a single logarithm like you see over there on the left. So let's look up at this first example that we had done really quick and see if we can figure it out. So look along with me. I'm going to start now with this on the right, okay? So first of all, remember how all of these plus signs meant that the logs came from the numerator? So that means that in the numerator, I'm going to have a 3. So I'm going to draw one big line because I know I'm going to have some stuff in the top, some in the bottom. So this 3 goes in the top. Next to it, I'm going to write, hey, this 3 is actually an exponent. So I'm going to write that as x cubed, and x cubed multiplies in the top. This 4 is actually the exponent for y, so I'm going to write y to the 4th in the top. And remember, they're all multiplying together, so we're not adding them. They go back together as multiplication. Now I see my first minus sign, so that tells me that this 2 here needs to go in the bottom. Ooh, I see a 1/2 in front of the log, so that means that must have been the exponent here. Well, x to the 1/2 is just another way of saying the square root of x. And there's a minus in front, so I'm going to put square root x in the bottom. And that's how we're going to go into, we're going to go backwards. We're going to condense, okay? So stay with me. Let's do this example here. So here's our steps. Step 1, we need to make our exponents visible. So here's what I mean by make your exponents visible. Any numbers that are being multiplied in front of our logs, those are really exponents. We need to rewrite them in the proper place. So cross it out, move it up here. That's x to the 4th. Cross this 3 out, that's really y cubed. And you can draw the arrow every time if you'd like. Cross this out, it's really a plus 1 to the power of 1/2. But wait, what's it mean to be taken to the power of 1/2? It means we're taking the square root. So go ahead and write the square root right away when you see the exponent is 1/2. Okay, so now we've made our exponents visible. Our next step is to condense them. So remember, when we're condensing, we're taking many logs and condensing them or squeezing them into just one single log. So you're going to write log, nice and big, log, big parentheses. So we got to fit them all in there. And then go ahead and draw a line in the middle because you might have some stuff in the numerator, you might have some stuff in the denominator. Now we're going to look one by one and start placing things where they go. So I have x to the 4th. Since there's no negative in front, it's actually a positive. That means it goes up top. So x to the 4th is in the top. Next thing I'm looking at is this y cubed. Where does that go? Well, look at the sign in front. The sign in front is minus 3. It was a minus log. So that means y cubed is going to go in the bottom. And this last one is the square root of a plus 1. Is that going to go in the top or in the bottom? You should be looking at the sign right in front of it. The sign is positive, so that means we're going to multiply this with what's already up top and join it up there. So the most common mistake that people make is they accidentally start adding things. You will never ever join things using addition. Remember, they all started as pieces that multiply. So this would be our final answer, something like log of x root a plus 1 all over y to the 3rd. Not so bad. Let's do another example. Step 1. Make your exponents visible. So let's see, let's scan. Do we have any exponents we can rewrite? So there's nothing out here, so we'll leave that guy alone. The second term, though, has a 2 in front. So cross it out, write it up there. It's going to be 3 squared. When our last term is a 1/3. So instead of writing 1/3 as an exponent, I can immediately write that as a cubed root, because that's what it means to have a power of 1/3. Now all of our exponents are visible, so we're going to condense. Remember, condensing means you have one big log. But notice what we have here. We have a base 5, so you have to write that in. It matters, okay? Keep track of your base. Okay, so let's start with this 2x minus 3. Is that going to go on the top or on the bottom? It's going to go on the top. Why? Because there's no sign out in front of it, meaning it's positive. So 2x minus 3 up top. Put parentheses around it. Next, what am I looking for next? I need to place this 3 squared, which is really 9. So you should not write 3 squared next. You should actually evaluate it. That's equal to 9. So where am I going to put the 9? In the top or in the bottom? Well, there's a minus in front, so it goes down here, 9. And the last thing I need to take care of is this cubed root m. So cubed root m is going to go in the denominator, again, because we have a minus in front. You're not going to subtract cubed root m. This is a common mistake. Remember, when you join all these pieces, they always multiply with one another. So it needs to be times the cubed root of m. So our final answer is going to look something like this. Log base 5. I'm just rewriting it a little more neatly. 2x minus 3 over 9 cubed root m. All right, let's do one more, and then I promise you we're going to get into the homework. Step 1, make your exponents visible. Scan for any numbers being multiplied in front. I have a 1/2 in front. Cross it out. That's going to be a square root. And nothing going on over here, so I'll leave that. Ooh, this last term has a 3 in front, so cross it out, make that a 2 cubed. Now, it would be pretty ridiculous to write in the next step. Remember, we're condensing it now. So 1 big ln, line in the middle. So this would be ridiculous. Do not write square root 4 in the top. Please, we know what the square root of 4 is, so we need to write it as 2. How did I know that went in the top, by the way? So look here, out in front, there was no sign, meaning it's a positive. Positives go up top. Next, let's deal with this x plus 3. Top or bottom? Look at the sign in front. It's positive. That means it's going to multiply up top. But there's a huge mistake with what I just did. I need the x plus 3 to multiply with the 2. I need all of this to multiply, so you need to put parentheses. Okay, last step, this 2 cubed. Well, what is 2 cubed? 2 times 2 times 2 is equal to 8. So that's what I'm going to write. And that's going to go in the bottom because of this minus sign in front. So that would be a great answer. I can also simplify it. I'll take 2 and I could distribute it in and get 2x plus 6 over 8. That would be the same answer. Or I could do one more thing, and I could, let's say, simplify 2 over 8 would become 1 and 4. So this would also be the correct answer. X plus 3 all over 4 because the 2 disappeared. So these are all equivalent. I kind of like this one and this one the best. All right, homework time. Let's do it. So problem number 1B. We need to condense. So let's scan. We're looking first to rewrite our exponents. That's a 2. Boom, that's really x squared. There's nothing in front of the log base 5, 3, so I'm going to leave it be. Time to condense. Whenever you see the word condense, this is what you need to do. Write one big log and draw a line. Some stuff in the top, some stuff in the bottom. So I'm going to do that log. Hey, we have a base 5, so you need to write that in. Okay, now let's see what goes in the top. Well, x squared is going to be in the top. And then look at the 3. 3 is also going to be in the numerator because it's a plus sign in front. So, like that. Hold on a second. I just made a huge mistake. See if you can catch it. Let me rewrite this. So we didn't end up having anything in the denominator, right? So I'm just going to rewrite this as x squared plus 3. But this is wrong. Why? What mistake did I make? Well, I joined x squared and 3 through addition, but that's not how our rule works. The rule says that these two things multiply together, right? So if I were to expand this, for example, it would become 2 log x, and then separately I would add log of 3. So I need to make sure that they're multiplying together when I join them inside. So this would be a good answer, x squared times 3, or log base 5 of 3x squared. They're both the same. Let's do problem number 1E now. Okay, step 1, make your exponents visible. So this 2 really used to come from, this 2 was really an exponent. And nothing else. Okay, we're ready to condense. So log base 4, big parentheses, some stuff in the top, some stuff in the bottom. Actually, scan the problem. Is there going to be anything in the bottom? I don't see any minus signs. This is positive out here, and this is positive. So I don't need to, I know I'm not going to need division. I can just save myself some time. So the first thing that goes inside will be 3 squared, which is 9. And careful, we need to multiply that with, what's the next thing? X minus 3. Use parentheses, please. Okay, if I said go ahead and, fix the inside, the next thing that we would do is distribute the 9. This would be 9x minus 27. But both of these answers are equivalent. They're both correct. Number 2C. Okay, we got to condense. Got a little bit more going on here, but same steps. First, let's make our exponents visible. So I see I have a number in front. I also have a number in front of my log here, so I'm cross them out. That becomes cubed. Cross it out, that's really squared. And I'm ready to condense. So notice we have a log base 6. the base matters. So copy it down. 1 big log. I'm noticing this minus sign, so I know I'm going to have something in the denominator. So let's start with x plus 1 whole cubed. That's going to go into my numerator because there's no sign out in front of it. And then x plus 1 whole squared is going to go in my denominator because of the minus sign in front of the log. Hey, something interesting is happening here. I'm told to simplify this all the way if I can. And I can, in fact. If I have x plus 1 cubed over x plus 1 squared, well then 2 of these x plus 1s are going to disappear, leaving me with just 1 on top. So my answer is log base 6 of just x plus 1 in the numerator to the power of 1. Last problem, I think. Yeah, last problem. Okay, so step 1, we're going to condense. Step 1, we're going to make our exponents visible. So make sure you're looking for anything first. If you skip the step and you go straight into condensing by writing like the big log right away, I can almost guarantee that you're going to forget to put this 2 up here. That's why you really, really need to make it step 1. Write in your exponents first. So this 2 is actually for x minus 2 whole squared. And now I know that I can put this up in the numerator because it's positive in front. And I'm going to go ahead and put x minus 2 whole squared in my denominator because it's a minus sign in front of it. The instructions say simplify if possible. So in order to simplify, I'm going to go ahead and factor the numerator, see if anything will cancel. So you go ahead and factor it whichever way is best for you. But eventually, so pause the video and actually do it, give it a shot. Eventually this will factor to x minus 2 times x minus 8. And my denominator is still x minus 2 squared. So look at what we got going on. I have an x minus 2 in the numerator, and I have an x minus 2 in the denominator. So one of them will cancel, leaving me with just an x minus 2 to the power of 1 at the bottom. My final answer is log base 5, x minus 8 over x minus 2. Ta-da! And that, my friends, is your lesson on the properties of logarithms. I think this lesson goes down as like the most colorful in the history of Ms. Nami's YouTube videos. I hope you enjoyed it. All right, bye.